All right. How's everyone doing? Yeah? I hope everyone on Twitch is doing well too. We still got a couple thousand people watching, which is fantastic. It's been a fantastic day so far. We just heard about serverless. Now we're going to talk a little bit about containers. Kind of a hot topic of debate. I'm on team serverless. Brent is on team containers. So yeah, he literally on the containers team. So if you're new to containers, if you want to understand how they can help make your architectures, your deploys, your operational overhead less, make everything better, then Brent's going to show you how to do that. So please give Brent a round of applause. Thank you.
I see knob. Still, here we are? All right, sweet. All right, so everyone can hear me now. Right on. Thanks, Brandon, for the introduction. My name is Brent Langston. I'm a developer advocate on the Container Services team. We're the team that brings you EKS, ECS, Fargate, App Mesh, Service Discovery, ECR, you name it. Like, we are working all about containers. And why are containers so useful? Why are they so sought after? Well, a couple of reasons, but one is because they make your code super portable. And you can use that to your advantage in a couple of different ways. One is it's portable and that helps make it deployable across an entire fleet of servers very easily. So you can build out your tooling, your workflow once, and then you can make decisions about, what language do you want to put in it? What language do you want to write? You don't have to build tooling per language anymore. And then the other thing is, if you decide you want to run on-prem plus in the cloud, you can do that as well, and we have offerings that can help do that. As I'm talking to people, I always run across people who are like, but how do I get started? What do I do first? And that's what this talk is really all about. So we're going to take a very simple application, a Hello World application, and we're just going to containerize it. And we're going to walk through kind of the decision-making process and how you can get it done, and then how you can optimize it and kind of make it into something that you could think of as being production worthy. So that was my slide. The rest of it's going to be live demo. And we're going to work from code that you can find out on GitHub already. And you don't need to follow along in person right now, but you can certainly fork this, take a look at it. You can open pull requests against it to improve it or whatever you decide to do later. So Docker Hello World. This is it right now. And what we're going to do is we're just going to start from the very beginning. So I have a directory here that I've already done this in once. Let's just get rid of it and start over. And for demonstration purposes, I'm going to use Node.js. So this could be any language. There's bound to be a hello world out there you can start with in whatever your preferred language happens to be. The one thing that I want to point out that I'm going to do here is I'm using a hello world that depends on Express. And I wanted something that would show a dependency. So it's super easy to write code that just spits out hello world. But what if there's a dependency that you need? So as of now, my app.js, if I run it, I get an error, right? Because it's looking for Express and it's not finding it. So how would we solve this problem? We would install Express, right? Well, think about if you had to do this across an entire fleet of web servers. And think about if you had some dependency that required a specific version. So how do you manage all of that? Used to, you'd have to manage it with config management. You'd have to have like elaborate chef recipes and cookbooks and all that stuff. and you'd have like one version per server, or you'd have some special language-specific way of isolating your code so that one piece of code runs in one directory and a different piece of code runs in another directory. What Docker gives us is all that functionality baked into a single artifact. So now we can containerize not just our app code, but also all the dependencies, and then we can push that to a server that may not even have Node installed and won't have Express installed, and we'll still be able to run our application. So hopefully in 30 to 45 minutes, we'll do exactly that with this particular application. So who knows Node? How do I solve this problem? Just shout it out. npm install, exactly. So npm init first if you want to get a package.json, and then install Express, right? So that installed Express. Did it do anything else? If we cat package.json, you see that we do list a dependency on Express 4.17.0, but if we look at package-lock.json, you'll actually see we installed a whole bunch of stuff. So it's not even just that there's one dependency, there's just one that brought in a whole bunch of other dependencies. And we want to manage shipping all that stuff around. So next up, let's make a container. So Docker, I feel like they really got it right when they started building the workflow for making containers, because they did it from the developer perspective. They said, you know what, all the code that automates building a container, we should have it live right alongside the app code. The developer should just own that. So whatever you have to do on a server, that's essentially what you should do in a Docker container. We'll look at some of the optimizations that you can do after that, but if you do nothing more than the commands that you run on a server, stick them in a Docker container, you'll probably get something that works. So let's start there. When you're picking out a server, you first usually have to pick out, what operating system am I going to run? Well, the Docker equivalent of that is from CentOS, or from Ubuntu, or from whatever operating system is your preference. So let's make a Dockerfile. And from CentOS. I like CentOS, so that's what we're going to start with. If I do nothing more than this, docker build docker build current working directory. This looks for the file, the special file name, Dockerfile with a capital D, and if it finds it in this directory, it just builds it. It follows all the instructions found within. We only have one instruction from CentOS, Docker images. Sorry. So with Docker, if I run Docker images, it's hard to see it. We won't see it right now, but because I only have the one line, I have CentOS in my images, and we see that that's equivalent to this particular image. So it says tag latest. I didn't say latest. Because I didn't specify any tag whatsoever, latest is the default. Generally, I want to tag things though, so that I'm very specific about the components that I'm putting in my container. So if we want to go and check out, what tags should I use, you can go to Docker Hub, look at and all of the major images do this, but you can look at the tags tab, and you can see latest was just updated 11 days ago, but also CentOS 7.6.18.10 was updated 11 days ago. So I'm going to copy that particular tag and use that. So let's go back over here, and we'll change our from line to CentOS colon, and then the tag name. So the tag name happens to also have the name CentOS in it. CentOS :tag. Now, we don't have to stop there. We can actually then add in our next commands. Copy dot current working directory destination dot the current working directory inside the container. We're going to copy our stuff, and then we're going to run node app.js. Sorry. So now let's Docker build. So we built our container. Is this going to work? Anyone know? I can tell you, it's not going to work yet. We'll see why though. Docker images. So I have this image, no name, no tag. I didn't tag it or any of that stuff. We'll look at that next. Docker run. So we have two things we want to fix. One, we didn't name anything, so we'll go back and we'll name it. And two, it looks like we don't have node inside our container. So we need to fix that too. Again, this is the kind of stuff that you work through when you're just like building out your little app server. So we're doing that just inside a Dockerfile instead. So let's do a few things. Let's actually name our container, and then we'll also build it. I'm going to paste in what our new Dockerfile is going to end up looking like, and then we'll delete the old stuff. So we're going to say from CentOS 7 whatever, then we're going to copy in our app code, then we're going to still run node app.js, but we're also going to install Node.js. And then, but to install it on CentOS, you need to first configure the repository to pull the installation. So I've keyed to Node 10. So we're going to download node source, the installer. That'll configure the repository. Then we're going to install Node.js, then copy our app code, npm install, or run npm install, and we'll talk about the rest in a second. Now, when it comes to building our container, Docker build, if I want to give it a name, then I can actually name it right in the command line. So Docker hello world. I'm going to tag it as latest just because I'm continuing to iterate on this. And again, current working directory. So you see how it's actually following the steps that I laid out in the Dockerfile. It downloaded the repository information. It just ran yum install for Node.js. And then it's going to copy my app code, run npm install, and we should be good to go. So Docker images, you see that my most recent image, 377 megs, is called Docker hello world and tag latest. Cool, right? Does it work? Let's check it and see. Let's Docker run. We'll talk about this command, what it all means here in just a second. But I have my running container. It outputs, hey, this looks like it's working, listening on port 3000. Let's test it. Curl localhost port 3000. Hello world. So I have my working container now. What did I do? What's different? What did I change? So I installed Node. I then added my app code, and I also added a step to run npm install. There's a step here where when I ran Docker run, I did it with init. I don't know, how many of you guys have already been using Docker containers? Have you ever run into the situation where you ran your Docker container and then you Control C and it won't die? Yeah, right? So do it with init. So what happens is you're running an application. Think about running it on a server. when you run any application on a server, it spawns a process and a init manages that process, right? And a init is what handles sending and processing signals. Well, that doesn't exist inside a Docker container unless you launch it with this command line option --init. So what's happening here is we're launching it and we're saying, okay, launch a tiny init that's built just for Docker, that's there just to spawn my command. And that way, when I press Control-C, it'll actually kill the container and give me back my shell. The other options in here are -I for interactive mode. I don't want it to fork into the background. When I'm testing, if I were going to run this on a server, I would want it to fork into the background. And then -P 3000:3000. If I leave this out, it's kind of interesting, and I make this mistake all the time, but if I leave that out, it all looks like it's working, right? But if I do my test, I can't get to my container. Well, inside the container, my app is listening on port 3000, but we haven't exposed that port outwardly. So we don't have any kind of listener that can send that traffic into the container. So there's a couple of options that you have available to you. If I'm only going to run one of these on a host, then mapping 3000 to 3000 is fine. But that means I can't run a second one, right? Because 3000 is already taken up. So I'd have to like pick a different port. Well, if I'm going to pick a different port, then why not just make it all dynamic? So there's a couple of ways to do that. On the command line, I think the easiest way is to just do -P. Now what -P does is it looks at the metadata of the container. I don't know if you remember, but I added a line that says expose 3000. So in the Dockerfile, you see this, expose 3000? That's there so that if Docker requests to get a dynamic port mapped, then it'll know what the target port inside the container should be. So I can certainly do that. And then I can run as many of these on a host as the host can actually handle. How do I know what the port is? What to listen on? Well, sorry, I meant to keep that running. If I docker ps, you can see that my running container has port 32769 forwarding to port 3000 inside the container. So while curl localhost 3000 won't work, the dynamic port 32769 will work and does work. So your choice. It depends on your workload, how you're going to handle running more than one container. But as far as just building a container, you just remember you're forwarding one port to another port inside. So outside port, inside port. That could either be dynamic or it could be static depending on what your preference is. When I'm developing and iterating, I always just keep it port 3000 to 3000 because I'm only going to run one and I don't want to have to sit there and look up what is the container every time. All right, cool. There's another thing that's probably notable though. I actually did something wrong when I built this container just now. If we go back and we look at the Dockerfile, this step here where I copy everything to the container, anyone know, anyone have off the top of your head what's wrong with doing that? What's wrong with that? He got it right. So his answer was, you copied the node modules directory. And that's absolutely correct. So it's not terrible. In this particular case, it'll actually work just fine. But what if there's a node module that needs some kind of compilation or something like that? It could actually not work. And then you'd be stuck in this weird state where everything looks like it built fine, but it's not actually running correctly. The other thing that you'll often run into, if you have your code under source control, and you should, then you'll be copying in like your Git history, the .git subdirectory, and you don't want to copy that either. That just makes your container super big, especially if it's been a long-running project. So leave all that stuff out. The way you do that, just like with Git, in fact, you'll notice Docker designed a lot of this stuff to model itself after the way Git works. But just like with Git, there's a git ignore. There's also a Docker ignore. So let's take a look at that real quick. I don't have one in this directory until now. So if we look at Docker ignore, I'm ignoring the Git subdirectory or anything .git, and then git ignore and the node modules subdirectory. Now, let's take a before and after. We'll scroll up a little bit to where I ran Docker build before. So here's my Docker build command, and you see that sending build context was almost 2 megabytes. So I sent to the daemon all the contents of the subdirectory, and that worked out to be almost 2 megabytes. That's how you know it's probably not right. If we build now, look at what I sent to the daemon now. Just less than 20 kilobytes. So I excluded all of that stuff that's sitting there locally that I built to see that the app runs, and I don't have to even have that anymore. If I want to run the app locally, obviously I do, but if I want to, I don't need it, and when I build my container, I want it to be reproduced inside the container from the build process. So if we look, I just built this 29 seconds ago. It's roughly the same size, so I think we're all good. We can test it again if we want. I guess we may as well. Just make sure, testing is always good. Port 3000. Hello world, it's all good. Right on. Okay, so I think at this point, you could actually stop, you could ship it, and it would work great. But we haven't optimized anything. So now let's take a second and let's talk about what are some of the kind of interesting behaviors of Docker and how we can use those to optimize our container and make it a little bit smaller. So you see that our container is 378 megs, Docker images, 378 megs. Let's try and get it to be smaller than that. How small can we get it? What's like a reasonable expectation? Let's go back and let me show you the sizes again. If we look, the image that I'm starting with is 202 megs. So if I'm gonna keep things with CentOS and that base image, then 202 is like the minimum. Like I can't go below that because that's my starting point. 378 is where I'm at now, so I think I can do better than that. But just set your expectations appropriately. Depending on how much work you want to put into this, if you're going to stick with CentOS, you won't get below 202. But let's see where we can get. Okay. So I'm going to copy this, and then we will talk through it. So we're going to keep the from. I didn't copy it because it wasn't capitalized, but there we go. I'll fix that. We're going to keep the from, and then this step where we ran curl and then we ran yum install. If you're building Docker files, one thing that you should watch for are cases where you have multiple run commands, and especially multiple run commands that are next to each other. If they're next to each other, they're almost certainly combinable. And if they're combinable, then that means that they go into the same layer. Here's one little secret about Docker in the file, the Dockerfile. Each line is a new layer. So what we're doing is we're starting with the CentOS base image, and then we're building a new layer on top of it, and we're saying, in that layer, run this curl command. and that's going to download and going to execute and going to run all the stuff that it's set up to run. Then we're going to build another layer on top of that. Every time we build a new layer, everything below becomes immutable. It becomes read-only. We can't change it after that. So if we download a whole bunch of stuff in one layer, and then we run like make install and we build our artifact in the next layer, and then in the third layer we go and we delete everything that we downloaded, that's great, but you get none of the space back. If you combine all that stuff into one layer, if you put it all together as one big step, then you can actually retrieve, process, and delete, and you don't have to give up all that space. So that's one really handy optimization that you can do. So we're going to do that. We're going to, instead of running the curl and running yum install, we're going to combine those into a single command. If you know anything about bash, the bash shell, you know that this is conditional execution, 2 ampersands, conditional execution. If the left side succeeds, we proceed forward with the right side. If it doesn't succeed, we stop, we fail. So after the curl command, I'm going to throw in a step of creating a user. We'll talk about that in a second. But then we're going to delete. We're going to clean up everything that we've done. Whenever we run yum goes out and fetches a whole bunch of metadata. And then whenever we install an RPM, it actually downloads that RPM into a cache directory and saves it. So we don't need that stuff anymore. Unlike a server, on a server we'll come back later and we might run other yum commands. So having that metadata cache is really handy. It'll make things a lot faster. You're never going to do that inside a container. That's one area where containers differ from servers. So because we know we're never going to do that, we're always going to go through this build process, we don't need this cache. In fact, we don't even want it. So we're going to delete it and try and free up some of the disk space. Now remember I said I added a user? One other difference between running stuff on a server and running stuff in a container, containers by default run applications as root. But we all know if you run anything on a server, you shouldn't do that. You should drop privileges and run as some kind of regular user. So the Docker way of doing that is to create your user account inside the container and then switch to it before you execute your code. So add user is creating it, and then the way I switch to it is by using the user command. The user verb switches to this user, then workdir verb switches to that directory, that user's home directory. That's where I'm going to copy in my application and then run npm install. All right, we're going to do this real fast. Save this file, Docker build. Uh-oh, npm not found. Actually, why is that? Did I not save the Docker file? Let me check. Oh. Bad editing. Got to get rid of this stuff up here. Not that stuff. There we go. So it looks roughly the same as before, but this time we're downloading, we're processing, we're cleaning, all in one layer. So we'll get to free up all that space. And now we have our image built. Let's check out images. Hey, not bad. We went from 378 megs down to 260 megs, and we didn't even have to work that hard. We'll work a little bit harder in a second. If I have, I have time. Okay, so let's also test again. Docker run. Curl. Still works. So Also, I switched to running as a non-privileged user. I'm just running as a regular user account, and you see the app still works just fine. So I didn't give up anything from a functionality perspective, but I increased my security posture substantially. Now I'm no longer running as root. So that's pretty great. Now there's one other optimization I want to point out, and this one isn't necessarily going to save us disk space, but it is going to save us time. You saw the Docker build, it took 10, 15 seconds. If we do it again, it doesn't take 10 or 15 seconds again. Anyone know why? I heard it from the audience, cache, exactly. Check out every single line of output here. You see that it says using cache. So what happens as Docker is processing that Dockerfile, it looks and it sees that like, hey, line 1 never changed. So I don't have to do anything different. I'm just going to keep what I already had. Line 2 never changed, so I'm going to keep what I already had. So we don't have to rebuild those layers. As soon as we hit a line that changed, we have to rebuild that layer, and as soon as we have to rebuild any layer, we have to rebuild every layer that comes after it. So what you want to do is move your stuff around, move your lines around in a way that'll still make sense, but in a way where the parts that change the most are the furthest down. So that way you're getting the benefit of cache for as many layers as possible. And that way you don't have to rebuild as much. So this will help your developer experience when they're building a container. They don't have to sit there and wait for 15 or 30 seconds every time they change their code. And by the way, this was a Hello World app. Think if I were actually installing a ton of NPMs, or I was actually like copying over a lot of data. The build process can actually take quite a while. So let's change this around a little bit. What I want to show you is if I change app.js, I'll show you before and after. So let's modify app.js. This is the part that'll probably be changing all the time, right? This is what the developer's working on. So instead of hello world, we'll say, hello collision. And now we'll build, and let's pay attention to the caches. So we got all the way to line 5 by cache. So that's pretty cool, but line 5 is where we copy everything over, and then we ran npm install again. We actually didn't need to run npm install again. None of that part changed. But because I was doing copy dot includes app.js, and because it includes app.js, that changed, and every line after that changed. So really, we don't want copy dot. What we want instead is 2 copies. One for package.json, and then one for app.js. So even though this adds a layer to my image, it's negligible, right? How big is package.json? And the fact is, it's going to be in one layer by itself. It was already on the image anyway, so I'm really probably not adding any space. I'm just adding a layer. But I'm getting the advantage of not having to rebuild those NPMs every time I change my app. So if I Docker build now, this is the before. We still have to run npm install because I changed that line above, copying package.json. But now let's go change app.js. And we'll just go back to hello world. And when we build this time, pay attention to the layer. Wow, right? That was almost as fast as the fully cached one. I didn't have to run npm install. It kept that line cached. Now, how big is the image? 261 megs. I think that's a really good trade-off. You get a ton of time saved by your developers. It's like as fast as they push enter, it's basically done. So they don't really have to wait around. but you also get still a relatively small container size. Now, we don't really have time to keep going, but I'm curious in the audience, what else would you do to shrink down this container? Use a different base image, exactly. That's what I was hoping I would hear. So there are other base images that are purpose-built for being a container base image. One extremely popular one is called Alpine Linux. Alpine Linux's base image starts at 3 megabytes. So I can actually, and in fact, if you want to see how it's done, well, all right, let's just do it. We have time. So I have an Alpine Dockerfile. I'm just going to copy this over the current one, and then we'll talk through it real quick. All right, so this is my new Dockerfile. So I tried to incorporate the same basic steps that we were doing in the CentOS one. Remember earlier when I said I was optimizing and I was trying to do it with very little effort? Well, this is more effort because really you have to learn a different package manager, a different distribution, but it's not that hard. And it's, there's a ton of documentation out there. So learning this might set you back 15 minutes. But it's worth it because you'll see what the image size is that we end up with. But same idea, I'm adding Node.js and NPM, I'm creating a user account, and then I'm copying my package.json, running npm install, copying app.js, exposing the port, and then running Node. So all the same stuff, just different package manager, right? Let's check it out. Docker build. Whoops, let's check for an error. Add app.js to the current working directory. Is missing a dot. All right, so I downloaded, I started, even line 1 couldn't be cached, couldn't use the cache anymore. So everything after that had to be rebuilt. But now that it's done, Docker images, we're down to 49 megs. So that was installing Node, installing NPM. If I want to get really fancy, technically I don't even need NPM once I've used it, right? So I could really install it, run npm install, then remove it. If I do that all in the same layer, I get to free up all that space. So I could really be fancy and do that, but you know what? I'm pretty happy with 49 megs. Let's test it. Docker run. It works exactly the same. Curl. I still get my hello world. There are some cases where Alpine doesn't work exactly the same. It uses a different libc than what you're used to. If you're used to most of the other popular Unixes, you're used to glibc. Alpine is compiled with muscle, so it's not the same thing, but it's almost the same thing. So for most cases, I think you can save a ton of space and therefore a ton of bandwidth pulling images by switching to Alpine. All right, so do we have any questions, or I don't know, what do we do at the end of all of this?
We've got a couple questions,
cool.
At least one from Twitch. So someone was asking, Carlitos10040. I always like to shout out the names so people know that we're actually paying attention. But he asked when it would be better to use a multi-stage build instead of the thing that you've just demonstrated.
I like that question. So the question is, when is it better to use a multi-stage build versus a single-stage build? I think the answer is if you can build something inside a container that you could more or less classify as an artifact, then it's super easy to just drop that into a smaller second stage container. So multi-stage build is use a big build environment. Don't optimize, just have everything you need to build your artifact. Maybe it's a Go binary, maybe it's a Java jar, something like that. But then once you're done with the build environment, you don't need all that stuff anymore. You can just create a second container and copy your artifact into it and have that be the runtime container, and it will have everything that you need to run. So, I think interpreted languages you might be able to do that with. It can be a little bit wonky, but compiled languages are almost a no-brainer. So like Go, C, Java, those are all easy to just have a multi-stage build.
Awesome. Another question from Geronimo, which is, what are the best practices to not run the app as root? You made it look really easy. Is that all there is to it?
That's the main one. This will keep you from running as root. There are also some operating system specific things, like if you're running on CentOS or Red Hat or any of the Red Hat derivatives, then you'll actually, if you enable SE Linux, not only would you not be running as root, but then you'll also be able to run inside a confined SE Linux jail that can help, like, further prevent container compromise. There's one additional thing that I've seen. I haven't yet been able to test it out, but there are some projects out there. Once you start getting past just containerizing and you get into orchestration, you might start looking at ECS, or you might even look at EKS. There are some projects out there that you can deploy to EKS that'll basically just give you sort of a checklist of here's what you're doing wrong. And it'll show that you're running these containers as root. You don't need to be doing that, and it'll hopefully walk you through fixing it. But the fix looks very much like what we just did inside that container.
Can you talk a little bit about how AWS containerization works with your code pipeline, and how to
I didn't hear the last.
Code pipeline, how you integrate with code pipeline and make the development, can you talk about that?
Yeah, exactly. So the question, if you didn't hear it, was talk a little bit about code pipeline and the development process. I can even point you at a pretty cool resource. So code pipeline, if you don't know what it is, it's basically our workflow engine that allows you to go from git commit all the way to deployed. And the steps along the way are kind of up to you to define, but there are some, sort of standard practices that you can follow that people have figured out, like pull from GitHub or pull from your Git repository, drop an artifact into an S3 bucket, send that artifact to code build, let code build that code. In our case, it would be building the container. Then it would shove the built artifact, the built container, into ECR, a registry that you can host containers from. From there, you would then need to trigger some kind of update, some kind of signal to say, okay, run my new container. Now that is up to your orchestration engine. If you're using EKS, it might be like a kubectl command. Anyone on the live stream, I always say kube control, so don't tell Chris Hine that I just said kubectl. He'll probably laugh at me. Okay, so if it's ECS on the other hand, it might be just like a CloudFormation update, or it might be a code deploy command to send out an ECS update. But either way, what you'll end up with, you saw we were using a Docker tag latest. The best practice is actually to use something other than latest. I personally like to use the git short hash, and I tag all of my containers with whatever the commit was that built that container. And I use the short hash for that, and then that's the only thing I'm updating. I'm saying, okay, go from running Docker hello world hash A to Docker hello world hash B. And that one line update will deploy out onto, and my orchestrator, that's its job. It just knows how to do that. It'll do it based on whatever I've defined as my rollout strategy. So code deploy is definitely worth exploring. If you want to actually see it in use and try it out for yourself, ECSworkshop.com. By the way, I'm going to point you at two resources since I'm up here. ECS Workshop and EKSWorkshop.com. Both are available for you to do. They're up 100% of the time. They're freely available. There's nothing that you have to do except bring your own AWS account, and you can walk through building an entire DevOps workflow using code deploy. So this will actually build out a code deploy that will take you from GitHub all the way into code pipeline. Will pull your code, just like I said, pull your code, start building it, shove it into ECR, and then deploy it out onto ECS. So the ECS workshop has all of that. You can walk right through it. It's super simple. If you want something that's a little bit more DIY, people that run Kubernetes tend to like to do things in a DIY fashion. So we have a couple of chapters available that you can focus on. One is CI/CD with code pipeline here. And then the other one is deploying Jenkins. So a lot of customers already run Jenkins, and they want to know, how do I run it inside containers on Kubernetes? So this is how you can get started running Jenkins on Kubernetes. I personally would shy away from that, and I'd stick with code pipeline. That's just me, though. All right, I'll be around. I'll be over there, actually, at across the aisle in the AWS booth. Come by, ask me any other questions that you feel like asking. I'd love to talk to you about all your container needs. Just let me know. Thanks.